All right, pause the video and try this warm up. So use the picture to create an equation of a sine graph with no phase shifts. All right, so here was the answer. Notice that when they're talking about sine, remember our formal definition would be y equals a times the sine of bx. They're talking about no phase shifts, so I didn't want to do like the c and then there wasn't going to be a d either. Okay, so I really needed to find a and b. So remember your sine graph, it starts at 0, 0, and I'm finding my 5 critical points. So that's what I labeled here. So it starts at 0, 0. There's 1, 2, 3, 4, 5. Notice that going from the starting to the second point, it goes up 3. So that tells me that that's going to be my A value. And especially when we have our picture and it's heading up, that's when A is going to stay positive. If it was at 0, 0, and then it went down to pi negative 3, well, then my A value would have had to be negative. Okay, then I counted to the 5th point, and that was at pi over 4. So that tells me that that is the period. And I needed the period to find what my b is. Remember, the definition for period is 2 pi divided by b. So because that definition equals 4 pi, think of 4 pi is over 1, cross multiply, and you'd be able to start solving for b. And that's where I came up with b being a half. So if A is 3 and B is a half, I was able to substitute those numbers in for the A and B in my formal definition, and there is my equation. All right, let's continue with section 5.7. We're going to do more with finding exact values of those composite functions. So let's just dive into some examples. We're going to find the exact value if possible. We're doing this without a calculator. So notice how this first problem here is dealing with cosine and inverse cosine. So remember, when you have the exact same trig function, you focus on the outside trig function to figure out what your interval is. And so because it's cosine, we're dealing with then going from -1 to +1 because that is what the highest and the lowest value can be because of the radius of the unit circle. Okay, so then once I have that, I'm looking at the number that is inside the parentheses to determine if it falls within the interval. And in this case, I noticed that 0.57, it definitely does fall within the interval from -1 to +1. So that's excellent. That means that that number is going to be a part of my final answer. The only thing that's a little bit different about this problem is that this time there's actually this extra number here. There's 2 times the cosine. So essentially, once I've recognized that 0.57 falls within the interval, that's only half of my answer. Because the 2 is being multiplied, I actually have to finish this problem out by multiplying by 2. Okay, so when I double it, that will be my final answer. So think about it. Without a calculator, you can honestly just add these together. So let's do some math here. 7 and 7 would add to 14, carry the 1. 5 and 5 is 10, plus 1 would be 11, carry the 1, bring down the decimal. We would end up with 1.14 as our final answer. All right, if I take a look at this next example, I'm noticing that I have inverse sine and sine. So once again, they're the exact same trig function. So that means I'm going to start with what's on the outside to determine what my interval is. Because it's an inverse, that means we're thinking about angles. So in this particular case, sine means I'm going from -pi/2 to +pi/2 with brackets because they are included. So once I know what my interval is, I'm looking at then the number that is associated on the inside, which is 7 pi/6. So if I'm thinking about my picture for a second, thinking about my unit circle, once again, 0 is here, pi/2 is up here, -pi/2 is here. 7 pi/6 is actually going to fall over here. Okay, it's in the 3rd quadrant. And so because I need to be focusing on the first and the fourth quadrant, we don't have it fall within the interval. So that means that we have a little bit of extra work ahead of us. So that means that I want to figure out what is the sine of 7 pi over 6. We already know that 7 pi over 6 falls in the third quadrant. So I'm going to sketch a right triangle in the third quadrant. Because my denominator is 6, that means it is a 30-degree reference angle. Think about your sides. Because it's in the third quadrant, both of your sides are negative. So across from the 30 is the smallest side, but it has to be -1. Across from the 60 would be -√3. The hypotenuse is always positive. So thinking SOHCAHTOA, sine is going to be opposite over hypotenuse. So that means that we want -1/2 as the sine of 7 pi over 6. So now my problem is we want to figure out what is the inverse sine of -1/2. And so to figure that out, I'm going back to my original diagram. I'm focusing on that -1/2 is either in the first or the fourth quadrant. Well, because it's a negative angle, that means that we are in the fourth quadrant. We're down here because that's 0. That's -pi/2. This angle is going to be a negative angle. If I know sine is opposite over hypotenuse, remember, any number that's across from that angle, being a 1, tells me that that's going to be the smallest angle. It is a 30, 60, 90 triangle. 30 is the smallest, but once again, we're going in a clockwise position. It's a negative angle. So my final answer to tell me what that theta is, -30 degrees would be -pi/6. And there is my final answer. Okay, let's look at some more. Let's find the exact value. We have the inverse cosine of the cosine of 2 pi. Once again, when they are the exact same trig function, start with what's on the outside. Inverse cosine tells me that I'm focusing on angles. That interval goes from 0 to pi, and that's included. Looking at the angle that they're giving us here, 2 pi. So thinking about my picture, I know that we're talking 0 to pi. Yeah, technically 2 pi is over here, but 2 pi is very different from 0, okay? They're not the same number. So that means that we do not have it fall within the same interval. So that means we have to do a little bit of work. I need to figure out what is the cosine of 2 pi. Well, if you think about your picture, though, 2 pi is a quadrantal angle. That means I need to think about this ordered pair. That ordered pair is at 0, 1, and cosine is always the first number in the ordered pair. So that means that 1 is going to be that value. So I really need to figure out what is the inverse cosine at 1. All right, so to figure out the inverse cosine of 1, once again, we're in between 0 and pi. But because we're dealing then with trying to find an angle, think about where is that 1? Well, we're dealing with the number 1 when we're talking about quadrantal angles, okay? Where does it become 1? Well, if I go back to my original picture here, that is going to be the ordered pair. That's the ordered pair 0, 1. Over here, this is the ordered pair 1, 0. Okay, so notice that over here, that's -1, 0. Over here, this would be the ordered pair 1, 0. Okay, so if I'm trying to figure out, well, where's cosine 1? It happens at 0. Okay, this was pi/2. So between our quadrantal angles that fit within that interval from 0 to pi, it was at 0. All right, taking a look at this next one, we've got inverse tangent of -pi/3. So once again, same trig function means I start on the outside. We're dealing with an inverse tangent, so that means that angles, we're dealing with -pi/2 to +pi/2, but not actually including those numbers. Okay, if I'm looking at then the angle that they're giving us, -pi/3. Asking myself, does it fall within the interval? So if you're thinking about the fact that negative pi over 2 is technically like a negative 90-degree angle, negative pi over 3 is technically like a negative 60-degree angle. So yeah, that number does fall within our interval. So when it falls within the interval, there's no extra work that we have to do. It's just negative pi over 3. All right, if I'm asking for us to find the exact value of the cotangent of inverse sine of 5 over 13, this is now a little bit different because we have two different trig functions. So remember, when they're different trig functions, you have to start on the inside. Inverse sine means we're looking at going from negative pi over 2 to positive pi over 2. Means we're focusing either on the first or the fourth quadrant. Because the ratio that I'm giving you, 5 over 13, is a positive number, that means I want to focus with drawing that picture in the first quadrant. Okay, sine is opposite over hypotenuse. So 5 is opposite, 13 is the hypotenuse. I want to know what that other side is. Well, hopefully you recognize that it is a Pythagorean triple. It's a 5, 12, 13 family. If you didn't notice that, you'd have to do Pythagorean theorem. So something like this is how you would have to calculate that out. But remember, when you have two different trig functions, I just needed to use the inside parentheses to sketch my picture. Once I have my picture, now I can focus on the trig function that's on the outside, which is cotangent. Remember, cotangent relates to tangent. If tangent is opposite over adjacent, I want to look at this picture and I want to know what is the adjacent over the opposite, because that would be my final answer. So from theta, adjacent is going to be 12 and the opposite is going to be 5. I can't simplify that any further, so 12 over 5 is my answer. Okay, let's do one more. I want to find the exact value for the cosecant of inverse cosine of negative square root of 3 over 2. Once again, two different trig functions means that I'm going to focus on the inside. Focusing on what's inside, I'm looking at inverse cosine. So that tells me that I want my theta to go from 0 to pi. So that means we're talking first and second quadrant. Looking at the ratio that's given to us, we are in the second quadrant, because if you're thinking about all students take calculus, first quadrant would have the positive ratio. So the second quadrant is where we would have this negative ratio. Remember, cosine is adjacent over hypotenuse. Your hypotenuse will always be positive. So that means that the square root of 3 is what's negative, and it makes sense because you're moving to the left. Hopefully you recognize that this is a special right triangle, so that means that the missing side is just 1. Technically, if you needed to, you could do Pythagorean theorem. But now that I have all my missing sides, I can focus on the outside trig function, and I can set up my ratio to get my answer. Remember, cosecant is the reciprocal of sine. If sine is opposite over hypotenuse, I'm looking for the hypotenuse over the opposite here. So using my picture that we just sketched, hypotenuse would be 2, opposite would be 1, and 2 over 1 gives us an answer of 2. So now pause the video and see if you can find these exact values. All right, so notice that because I had two different trig functions, I focused on the inside for the first one. So I wanted to know what was the inverse tangent of 1. So that means I'm focusing on negative pi over 2 to positive pi over 2. Because I'm dealing with a positive ratio, I was in the first quadrant. And so that ended up being the angle of pi over 4. But because there was that extra number out in front, I needed to multiply 4 times pi over 4. That gives you then just pi. So sine of pi is what I was looking for. That is a quadrantal angle. Okay, pi is over here. Thinking about what that ordered pair is, that's the ordered pair, negative 1, 0. 0 is the second number in the ordered pair, which is why 0 was my final answer. Second problem, notice that we're dealing with the same trig function. So I start with the outside. Notice that inverse tangent means we go from negative pi over 2 to positive pi over 2. Because 3 pi over 4 is not going to fall in that quadrant, I need to figure out what is the tangent of 3 pi over 4. Well, 3 pi over 4 is going to fall in the second quadrant. So if you're thinking about the second quadrant and you draw a picture, tangents opposite over adjacent, your legs are the same, they're just opposite signs, so it's going to turn into -1. So I want to know, what is the inverse tangent of -1? Well, going back to my original interval, because I have a negative ratio, I'm in the fourth quadrant, and it ends up being the negative angle of negative pi over 4. Finally, in this last checkpoint problem, once again, two different trig functions. Focus on the inside first. Inverse sine means we go from negative pi over 2 to positive pi over 2. Because my ratio is a positive, that's why I sketched a picture of a triangle in the first quadrant. Sine is opposite over hypotenuse. I had to do a little bit of algebra to figure out what that third side was. So using the Pythagorean theorem, I figured out the missing side was the square root of 21. Once I have that picture, now I can focus on the cosine. Cosine is adjacent over hypotenuse, so that's why I came up with the square root of 21 over 5. So there's us finding exact values of the composite functions with inverse trig functions.